Hello everyone. Hello everyone, welcome to Gradeup. It's 6 p.m. and we are live again. So, hello once again. We are here for the Gearup JE session, the session on mechanical course, the mechanical course for RRB SSC that is going on. Some of you were complaining or they were asking that this course is now not being running after we have launched the full course, the paid course, but it's not like that. Okay, this course will run for some more time. There will be few more subjects that will be covered in this. So I will wait for some more time for some more viewers to join us. So those who are already live can show their presence. So now I can see a few number of students who have joined us. We want more of them. So this course, the Gearup JE course, yes. Okay, good evening to all those who have joined us. So this is what I am telling you, the Gearup JE course. This is that free video course, the free YouTube course which we were running. Okay, so some of you were complaining that this video course have we stopped this course? Okay, no. So the answer is no, due to some reasons. The class, there were 4 classes that I told you that were scheduled for this subject of machine design. Okay, the first class we conducted on 1st of April, that was the introduction and the syllabus discussion. The class of 4th April, that is the class on design against fluctuating load, that class was conducted on our gradeup classroom. Okay, and that was a free class. That was a free class. That day the class was conducted on gradeup classroom. Okay, so you might have got that notification. Okay, everyone, the class was run on gradeup platform that day, the classroom platform. Okay, and today the next class that was scheduled for 8, the class on brakes and clutches, due to some reasons that class was not being conducted. But today, as you can already see in the comment section, in the live chat, in the starting we have posted that comment that today the class will also consist of the topics of brakes and clutches. Okay, though the class topic is important MCQs discussion, but the class will also consist the topics of brakes and clutches. Okay, so there will be the topics of brakes and clutches, and then we will be moving on with the questions, important questions discussion. Okay, so many of you were complaining that have we stopped this course. So we have not stopped this course as of now. Okay, but again it's my request to you that it would be better that if you prefer the full course, the paid course over it. Okay, I am not going to make a big promotion of that course here, because otherwise I get a blame of promoting the course. Okay, so I will not going to do that here. This is just the class for studying, and we will start that as soon as possible. And any problem if you are having in anything regarding the preparation for your RRB and SSC, for the technical part, I can say that you can purchase the course, otherwise it's your wish completely. Okay, so without wasting any one of your time, let us begin the class with the first topic of clutches. First of all, we will discuss about clutches. Then we will discuss about the brakes. Okay, and then there will be the important classes. Then the important questions discussion will follow. Okay, so now what is clutch? This class will go a bit faster because I have to complete 2 topics in this, that is the brakes and the clutches, and then the important questions. I don't want the session to be extended beyond 7:30. Okay? So, discount is there. Discount is there. You don't have to worry about it. Is there any issue regarding with the sound? Am I audible clearly? Any one of you, please confirm. The link for design of fluctuating loads that you will get. Okay. I request the chat moderators to please give the link for the design of fluctuating load, the classroom link. Okay. I request to the chat moderators please to give the link. Okay. So, is it audible now clearly? No problem with sound. Okay then. Thank you. So, first of all, we see what is a clutch. How a clutch is defined. Okay, I got it. Yes. So, clutch is a device which is used for the engagement and disengagement of the prime mover with the rest of the parts. Okay, of a machine which is used to engage or disengage a power source to the transmission shaft. Yes, that is what we are saying. The power source or the prime mover, you can also say it. Okay, from where the power is being generated. Okay, and with the rest of the parts, that means the transmission shaft and all. Okay. Is it okay now? The definition: engagement and disengagement of the primary mover with the rest of the parts, and that also with the will of the operator. Means whenever the operator wants, he can make the engagement, and whenever the operator wants, he can make the or he can disengage that part. Okay. So basically there are 4 kinds of clutches, the 4 classification of clutches that I am going to tell you here. Okay. The first one is the fourth one. Okay. The first one is a positive contact clutches. The first one is a positive contact clutches. The second one is the friction clutches. The third one is electromagnetic clutches. And the fourth one, the final one is the final one is the fluid clutches. Machine design is not explicitly mentioned in the syllabus of RRB JE, that I have already told you in the first class itself. Okay. But in the SSC JE and other JE examinations, this subject is included. Okay. It is not included in the syllabus of RRB JE. Okay. Explicitly it is not mentioned. Okay. So, positive contact clutches means in this the power is transmitted by means of interlocking of jaws and teeth. Interlocking of jaws or teeth. Okay. In this the power is transmitted by means of friction, as the name is there, by friction. In this case the power is transmitted by the means of magnetic field. Magnetic field. And in this case the power is transmitted by the means of fluid pressure. Fluid pressure, the fluid pressure can be oil pressure or the air pressure. Okay, the oil pressure or the air pressure. Okay, so the types of clutches or the clutches which come under the category of positive contact clutches are like your jaw clutches, toothed clutches, okay. All these are the are the types of clutches which comes under the category of positive contact clutches. Then in the friction clutches comes like your single plate clutch, the multi plate clutch, the cone clutch and the centrifugal clutches. In the electromagnetic category comes the clutches like your in the electromagnetic comes like the magnetic particle clutches, the magnetic hysteresis clutches and the eddy current clutches. They comes under the category of electromagnetic clutches. And in the case of fluid clutches, there are some clutches which are operated by the hydraulic pressure or the fluid pressure, either the oil pressure or the air pressure. Okay. Similar will be the categorization for the brakes as well. When we will study the brakes, I am not going to repeat this classification. The fluid brakes are there, or the hydraulic or pneumatic brakes. The electromagnetic brakes are there, and there are the friction brakes. Which are the brakes that we generally use are the friction brakes. Okay. The shoe brakes and all, they are the friction brakes. The bend brakes, friction brakes, the bend brakes, the short shoe brake, the long shoe brake, all these are the friction brakes, comes under the category of friction brakes. Okay. Next. So only the topic which is included in the study of mechanical engineering is the friction clutches. No other types of clutches are used. Only this is a bit given, but this concept is used, that how the hydraulic pressure is used. That is, we study in the subject of fluid mechanics, where we study about the, or basically the hydraulic machinery, where we study about the actuators and all, the hydraulic actuator, the hydraulic ram and all. There the concept comes how this air pressure is used for that. But the topic of fluid clutches in nowhere in the syllabus of mechanical engineering, and similarly the electromagnetic clutches are not there, and the positive contact clutches are also not there. Only we have to study the topic that is friction clutches. Okay. So now friction clutches, we will study only the friction clutches. MCQ will start after some time. Wait, because I did not complete this topic of brakes and clutches. That's why I am taking it. Otherwise, I will again get the blame that I skipped this subject or we have stopped this course. Okay, I don't want to get that blame again. Okay, because we are doing a lot of efforts for you guys. Okay, you students, and if after that, if a teacher or a faculty gets blamed, that's not good. Okay, so friction clutches. Friction clutches, now you have understood that the power is transmitted by means of friction. Okay, so I don't need to repeat that point again. Now I will just move on to the analytical part of this, or basically the advantage I can write one or two. The advantage is engagement is very smooth. Okay, engagement is smooth, and I can also write one more thing, that slip is 0. Slip between the engaged and disengaging parts are 0. Okay, at the start of engagement there is machine design nahi hai RRB ke syllabus mein, I know, but you can also see the title of this course or the class, that is for the RRB and SSC JE both. Okay, these classes not only for RRB JE, this is the topic is included, or the questions are coming in the other examinations like the SSC JE and all. Okay, so if you are specifically preparing for this subject, for this exam of RRB JE, so in that it is not included, but in the subject of SSC JE, FCI JE, okay, 2 other JE exams are also lined up for mechanical engineering. There this subject is included. Okay, so I was talking about the slip is 0. That means during the engagement and disengagement there is initially the slip, but once the engagement is complete there is no slip. That's why I am writing here that the slip is 0 for this. Okay, now I will write The next thing, that is the torque transmitting capacity of this clutch. Okay, torque transmitting capacity of this clutch. Torque transmitting capacity. So first of all, let us write some of the notations which are used here, like this is the inner diameter, this one is the outer diameter, okay. This is the inner diameter, that is the outer diameter, and then there is one more thing, that is the applied pressure. If this we see the side view, so this plate, the engagement will be in this part because this is the plate, okay. Other is a hollow part in the middle, okay. This is the hollow part, okay. So if we apply the pressure onto this one, this, so small d is the inner diameter of the clutch plate, capital D is the outer diameter, and this P is the applied pressure, okay, that is the applied pressure. Small p you can write, okay. There will be two things that you need to, first of all, there will be one small p, that is the applied pressure, okay, and there will be one more notation, that is capital P, that is the total operating force. Total operating force, okay. Don't get confused between these two, small p and capital P. Small p is pressure, capital P is total operating force, okay. So now what we see, the derivation for this is a very bit simple, okay. Just I am going to tell you how to do that if you are really interested in that, okay. So take a radius r and a strip of thickness. At this radius r, take a strip of thickness dr, okay. The diagram may not be that much clear, but what I am saying, just focus on my words as well. At a radius r, take the thickness, the ring of thickness dr. So the area of this strip or this ring will be how much? 2 pi r dr. This will be the area. The area will be equal to 2 pi r dr, okay. And if this is the applied pressure, so pressure into area will give you the force, okay, that will give you the force. So that will be the force on this ring only, that will be 2 pi r dr into small p. This is a small p, okay. 2 pi r dr will be the, suppose I can write it as df, that is the force on this elemental ring of at radius r at a thickness of dr, okay. Then this is the force. Now the total operating force, that will be equal to the integration of this, okay. The total force will be the integration of this, that is this capital P is equal to integration of 2 pi r dr. The radius will be from inner diameter, from inner radius, that is small d by 2 to capital D by 2. This we get the first equation of clutches. Is there any difficulty till this part? This is a very simple thing which I am telling you, okay. This is capital P. This is capital P equal to 2 pi r dr into small p as well. Small p as well is there, okay. Then this is the total operating force. Now to find out the friction force. The frictional force will be equal to this force multiplied by the coefficient of friction, that is mu, because this is the normal force that is acting on the plate. So mu into this capital P will give you the friction force, that is mu 2 pi r small p dr integration from small d by 2 to capital D by 2. Okay. Then to find out the frictional torque, what you have to do? To find out the frictional torque, the frictional torque will be given by this multiplied by again the radius, because the frictional torque or the torque is nothing but the force into area. Since this is the frictional force, so this will become the frictional torque. Okay, and that frictional torque will be equal to this expression multiplied by again the radius. So you will get it as mu 2 pi r dr small p into r, and that integration remains as it is, small d to capital D by 2. Okay. आवाज अटक अटक के आ रहा है. Anyone again? Anyone else facing the problem with this sound? Is there any chance of decrease in what? Decrease in what? Please write it again. Completely write what you want. Decrease in. Okay. So from here you can see this 2 pi and is constant. So that can be taken out. Okay. This 2 pi can be taken out. So this can be written as 2 pi integration of P r dr d by 2 capital D by 2. Okay. Here also you can take out this 2 pi and mu outside. 2 pi and mu outside can be taken out because these are the constants. So this equation can also be written as 2 pi mu integration from small d by 2 to capital D by 2 and P r square dr. P r square dr. Okay, P r square dr. Okay. Frictional torque can be denoted by, it's up to your wish by which you can denote, but in most of the books it is written by like this. Okay, MT. Video and voice दोनों अटक रहे, तो I think there may be some issues with your internet. There may be some issues with your internet. Kindly reload the page. Okay. Is there any chance of decrease in the RRB? If you are asking about the fees, okay, if you are asking about the fees, so I must tell you clearly that if you have taken the CBT 1 course, if you have taken the CBT 1 course, then there is a flat discount of 2000 rupees for everyone who have purchased the CBT 1. Okay, and for rest, there is no decrease in the paid course. There is normal video and sound. Okay then. Okay. So now you can see that there we have arrived at two expressions. One is this one for finding out the total operating force, and one this one that is for finding out the frictional torque. Okay. Now see what happens. Now see what happens. I am rubbing this off. Okay. The capital P, that is the total operating force, is given by 2 pi into P r okay. No, there is no chance in the decrease of fees. The fees is rather going to get increase. Okay, it's not going to get decrease. Okay, this is from small d by 2 to capital D by 2. Okay, And for the frictional torque, we have 2 pi mu p r square dr in small d by 2 to small d by 2 to capital D by 2, that is PR square dr. Okay, now there comes the two theories. Now comes the two theories which are applicable for the clutches. The two theories are, the first theory is uniform pressure theory, and the second theory is uniform wear theory. Okay, machine design is not in the syllabus of RRB JE, that I also know, but as I already told you that these classes are for not only for RRB but for SSC JE as well. Okay, so now this one, uniform pressure and uniform wear theory. So for the uniform pressure theory, we have one thing, that is this applied pressure Okay, so now for the uniform pressure theory, we have this applied pressure, that is small p, is equal to constant. Okay, this is equal to constant. And for this uniform wear theory, there is one another expression. Okay, so now see this, if the uniform pressure, if we applied, so these are the name of two theories, I will take them one by one. So if we talk about the uniform pressure theory, so in this case the P will be constant, so the total operating force will be equal to, if this P is constant, so it can be taken out of the integration, you will get it as 2 pi small p integration of r dr from small d by 2 to capital D by 2. Okay, and when you will integrate it, you will get the expression as 2 pi small p r square by 2. Okay, r square by 2 from small d by 2 to capital D by 2. Okay, so here you can use that is 2 pi p d square by 4, and this will be 2 more, that is 8. So this will be 2 by 8, this is 1 by 4. So this will be pi into small p by 4 d square minus d square. This will be the expression which you must know, that this is the expression for capital P. Capital P, that is the total operating force, is given by pi p by 4 d square minus d square. Okay. Next is, if we find out the MT, that is the frictional torque. So the frictional torque, if this P is constant, it can also be taken out, that is MT is equal to 2 pi mu. P is taken outside, this will be r cube by 3. Okay, capital small d by 2 to capital D by 2. Okay. So this will give you the expression as, this will be d cube by 8. Okay, and that 8 will become 4, so this will be 12 pi mu p by 12 d cube minus d cube. Okay, pi mu p by 12 d cube minus d cube. Okay, this will be the expression. And when you find out in terms of operating force, that is the total operating force. Okay. So if you find out in the terms of total operating force, if you divide this equation by this one, that is if we call this equation as 1 and this equation as 2, and if we divide equation 2 by 1, what we get? See, dividing equation 2 by equation 1, we get mt is equal to, see this, pi p will get cancelled, so there will be mu remain, and this 4 and this, that will be 3 will remain. Three remains. This is what we are doing, capital P. And then here will be d cube minus d cube over d square minus d square. Okay. So Vinay Kumar, if you are facing some problem with our app where the transactions are always failing, what you can do, you can just write your query on, I'm just giving you a email ID, help@gradeup.co, help@gradeup.co, there you write your query, and also there is one mobile number that I am giving you, 96500 52904. 96500 52904. There you can register your queries that I am trying to make a transaction but they are always failing. They will assist you in this regard. Okay. So this is the final expression that we can get if we remove this. So we will get mt in terms of total operating force as this one, that is mu p by 3 d cube minus d cube over d square minus d square. Okay. In the case of multi-disc clutches, this is only for the single brake, means single plate clutch. Single plate clutch we are discussing this. Okay. So next if we see, this was for the uniform pressure theory. Now we consider the uniform wear theory. What is that? Okay. So let me tell you one more thing here, that the uniform pressure theory is applicable for the new clutches, uniform pressure theory is applicable. And if I talk about the uniform wear theory, that in the case of uniform wear theory, this is applicable for the old or the worn out clutches. For the old or the worn out clutches, what we see that this P, that is the pressure intensity multiplied by R, is the wear is directly proportional to this thing. The wear is directly proportional to P into R. Okay, that is the pressure intensity multiplied by the radius. So when we are talking about the uniform wear theory, that means the wear is constant. So if the wear is constant, that means P into R is also equal to constant. Okay. So P into R is constant, that means the pressure is inversely proportional to the radius. That means at the inner radius the pressure will be highest. Rishabh, I am not able to understand that. Others are saying that the video and the sound is going absolutely fine. Okay, how come only with you I am not able to understand that? Okay, that you are facing the sound issue. So if PR is equal to constant, that means pressure is inversely proportional to radius. That means pressure will be highest at the inner radius. The pressure will be highest at the inner radius and it will be lowest at the outer radius. So in the case of uniform pressure theory, if we try to make a pressure diagram for this, okay, if we try to make a pressure diagram for this, this will be that the pressure will be same. The pressure will be same both at the inner radius as well and the outer radius as well. Okay, because in that case the pressure was constant. But if we try to draw the pressure diagram for this case, so here it will be somewhat like this. At the inner radius, the pressure will be highest, and at the outer radius, it will be lowest. So the pressure intensity will look somewhat like this. The pressure diagram will look somewhat like this. Okay. The pressure diagram will look somewhat like this. Maybe this is not visible to you. At the inner radius, the pressure will be maximum, and at the outer periphery, the pressure will be minimum. Okay, the pressure diagram will look somewhat like this for the uniform wear theory. They are not responding, sir. Did you make a phone call to them? I want someone who is right now looking into all these chats, moderating all these chats. Please make sure that the person is facing some issues regarding the transactions which he is trying to make. Not only he, but he is saying that many of his friends are also doing that. So kindly take up that issue. Okay. Kindly look into that and take up that issue. Anyone who is who is looking into all this issue, he is saying that they are not responding. So I want someone to look into this issue. Okay. Vinay Kumar, don't worry. Don't worry. I will take up your case personally. They will surely respond to you. Either if they are not responding to your call, what you can do is drop a mail. Okay, I have also given the email ID, that is help@gradeup.co. You just drop a mail there. Okay, they will surely reply. I will look into that matter personally. Okay, Vinay Kumar. Yes. And ask other your friends, those who are facing the same problem, you can just tell them to do the same as well. Okay, just drop a email ID, just drop your query at this email ID, help@gradeup.co. Okay, so now moving forward, if this is constant, so we have these two formulas, that is, so in this case, now PR will be equal to constant. Okay, so PR will be equal to constant. So PR will be equal to constant, that means PR will have some value, and that PR is equal to, suppose, PA into D by 2. Okay, PR is equal to constant, that means PR is, let us take that PR is equal to PA into D by 2. This D by 2 is the small radius, and this P is the maximum pressure. This maximum pressure, this is denoted by PA. Okay, got it? So now, just using that expression in the place of PR, you can use this PA. This PA is basically this A subscript. Okay, so PA into D by 2 use in the place of PR and integrate this one as well. And here, using P into R as PA into D by 2, and then R will remain, integrate that, and you will get the expressions as, I am directly writing the expressions for you. Okay, you will get the expressions for this total operating force as, for the total operating force, that is capital P, you will get the expression as pi PA D by 2 capital D minus small d. This you will get. Okay, this you will get. And next, if you find out the frictional torque, that is MT, you should get the expression as pi mu PA D by 8 D square minus D square. This is suppose expression 3, or this is expression 4. Okay, and now if you divide this 4 by 3, you will get something as pi PAD will get cancelled. This will be by 4, and this is D square minus D square, that is D minus D, D plus D divided by D minus D, so you will be left with D plus D. Okay, and this will be equal to, if you multiply this by capital P, you will get this as MT. So for the case of uniform wear theory, the frictional torque in terms of total operating force is equal to mu P by 4 D plus D. Okay, and here it was mt equal to mu p by 3 d cube minus d cube over d square minus d square. Okay. So this is about the two types of clutches. That is the two theories which are applicable for the cases of clutches, that is the uniform pressure theory and uniform wear theory. Okay. Now if we talk about one important term, that is the friction radius. What is the friction radius? Okay, just put one heading there, that is the friction radius. Friction radius, if we talk about friction radius, so if we write mt is equal to mu into capital P into Rf, that is the friction radius. So if we equate these two equations, suppose this is equation number A, this is A, this is say as B, and this is as C. So equating A and C, we will get that the friction radius for the case of uniform pressure theory will be equal to Rf is equal to 1 by 3 d cube minus d cube over d square minus d square. That is for the uniform pressure theory. And if we talk about the uniform wear theory, for the uniform wear theory, this will be equal to 1 by 4, the Rf, that the friction radius is equal to 1 by 4 d plus d. Okay. I hope you get this much. That is, these are the two types of theories which are applicable in the case of clutches, that is the uniform pressure theory and uniform wear theory. Then there is one more important thing, that is this was about the single plate clutches. If there are multi plate clutches, then what happens? If there are multi plate clutches, nothing happens, only these formulas gets multiplied by the term that is Z. Okay, they only get multiplied by Z, and that Z is known as the Z is known as the number of pair of contacting surfaces. Okay, this Z is known as number of pairs of contacting surfaces. Okay. So number of discs, if you see, the number of discs will be equal to this number of pairs of contacting surfaces plus 1. Why? Because see, if there are two discs, they are in contact. So the number of pairs of contacting surfaces will be 1, but the discs are 2. Okay. See, if these are the two discs that are in contact, so they have only this portion with contact and they are two discs. If we introduce one more disc, that is 3, so the number of pair of contacting surfaces will be 1 between disc 1 and 2 and between 2 and 3. So the discs are 3, but the number of pair of contacting surfaces is 2. Here it is, in the case of only two discs, the discs are 2 and the number of pair of contacting surfaces is equal to 1. So here this formula gets applied, that is number of discs is equal to Z plus 1. Okay, if Z1 are the number of discs on a driving plate, okay, and Z2 are the number of discs on the driven plate, then number of total discs becomes Z1 plus Z2 is equal to Z plus 1. So from here we can get that Z, that is the number of pair of contacting surfaces, will be equal to Z1 plus Z2 minus 1. So from where you get to know one important thing, that is the number of pair of contacting surfaces is equal to the total number of discs be it on the driving side or on the driven side, minus 1. Okay, got it? Okay, so now moving on to the topic of brakes. Okay, this much is enough for the topic of clutches for the JEE level examinations. Okay, so moving on to the topic of brakes now. Okay, I can see these days the number of students in these live sessions, especially for the CBT2 examinations, are decreasing very drastically. I don't know why. Right now also I can see less than 20 of you live right now, 15 to be precise. Okay, so may I know the reason for all this, because previously when we were conducting all these classes, we used to get a really good kind of response from your sides. But now as I can see that the number of students are getting very decreased. Okay, are decreasing day by day. I don't know why, whether you are preparing or for any other examination, the CBT1 and all, or what's the reason for that. Because there were many of you, maybe some of you are live right now, I cannot say that, but many of you were asking that whether this course is going to get continue or not. Okay, so if we are giving you this course or these videos for free, even if we are completing only 25 to 30% of the syllabus, but still we are giving you some things to learn, to understand the concepts and all in these free videos as well. So those who are live right now can tell us that why is this all happening? Because if such the scenario will continue, if the number of students, if you are really not interested and if you are thinking that you will be able to clear the CBT2 examination after, or if you will start studying for the CBT2 examination after you get your CBT1 result, so I don't think that it's a good choice to make. From my point of view, the schedule mismatch. Which kind of schedule mismatch is there? We are taking, the classes are being conducted, okay, the Gearup JE classes are always being conducted at 6 PM only, and we have also clearly defined the dates and all. Okay, we are not taking the classes at any other time or at any other dates as well. Okay, but if these kind of situations, the scenario will continue, so I don't think that there is any benefit of us, okay, giving you these kind of classes. So these classes, if the response becomes such, these classes are surely going to get stopped very soon. Okay, so today class will continue, but because today is the last class of this subject, so we have to think for the starting of the next subject. Okay, because it's not like it's not like ki just we can come here and give you some questions, some theory and we go. Okay, because everything takes a lot of efforts behind the screen. It takes a lot of effort to be standing here and delivering you these kind of lectures. Okay, from our sides as well, and behind the scene there are too many people who are creating all those things, all those efforts. Okay, so everything requires a lot of efforts. So if the people are less interested, the students are less interested, so we will surely going to wind up this free series after this subject, or even not after this subject, very soon. Okay, at max we can continue for one more subject after this, not more than that. Okay, so now today, don't get distracted right now. Right now the class will continue for one more topic, and then there will be important MCQs discussion as well. So brakes. Starting with the topic of brakes. So first of all, what is a brake? A brake is a device which is used to slow down a moving object. Slow down a moving object. Okay. And the energy, whichever forms the energy has, the body has, okay, that is taken up by the, so device which is used to slow down a moving object. So after whatever kind of energy that the moving body possesses, that is absorbed by the brakes. Okay. We follow our timetable very strictly. I have already told you that only this topic of brakes and clutches was missing, that I am conducting today. So we haven't violated our timetable anyhow. Okay, we haven't violated our timetable anyhow. If you say that please follow your timetable, so we are following our timetable very, very responsibly. Okay, because this topic was left. Today was the class. You can see in the title of this video also, there was only the class. The title is also written as important MCQs discussion. But I am taking the class on clutches and brakes because due to some reasons that day the class could not be conducted. Okay. It was not my liability to take the class on brakes and clutches today, but still I am taking because I know my responsibility that if any one of you are following these videos, so and if you are following our plan in the first class of the machine design, I told that there will be 4 classes. So the 4 classes we have conducted, although we have conducted although we have conducted the one class on the design against fluctuating load on classroom, but we conducted that, and that is a free class that the link will be provided to you. You can watch that class as well. Okay. Free class end होने के बाद बना रहता है. It's always available on this platform, this YouTube platform. Okay. But it's my request that you watch these if you can arrange for some time, because we are not conducting the classes on a 7-day basis. We are conducting the classes on a 3-day or 2-day. Now we have restricted our schedule for only 2 days a week. Okay, so it's my request that if you can arrange for some time for these 2 days, 2 days in a week, 1 and 1.5 hour at max. So the importance of live classes is different. Okay, watching a recorded video afterwards is a different thing. Okay, but in the live class you gets the chance to interact. If you have any problems, you can ask it there and there. Okay, and gets all your doubt cleared. Okay. So I'm not scolding anyone, I'm not criticizing anyone. I'm just saying that if we are giving that much of efforts from our side, it's better that you understand and you try to grab those opportunities. Okay, because otherwise the paid course is there, you can go and purchase that course. We don't have any issues on that. Okay, that will be the full-fledged course. The complete syllabus will be completed in that. Okay, the 100% syllabus included with the study notes and the quizzes. Okay, so now moving on to this. So if that object is moving, is having the kinetic energy. Okay, if the mass is m, v1 square minus v2 square. If the body is having the initial velocity as v, final v1, final is v2. So this one will be the energy, that is the kinetic energy that will be dissipated or that will be absorbed by the brake. If the body is having the potential energy as mgh. Okay, so depending upon which kind of energy, okay, potential energy. So depending upon which kind of energy the body has, whether it has the kinetic energy or whether it has the potential energy, any kind of energy that the body possesses, the brake can absorb that. Okay, and the brake can absorb that in the form of E equal to mt into theta. Okay, mt into theta. this energy and this energy are all same. It can be the kinetic energy, it can be the potential energy, mt multiplied by theta. This is the braking torque. This is the braking torque and this is the angle turned by the brake during that in radians. Please remember that the SI unit of theta or the angle moved by the brake is radians. Okay, so braking torque multiplied by radians will be the energy. That energy will be absorbed. So this is the energy consideration for the brakes. That is, energy can be either in the form of kinetic energy or in the form of potential energy, whatever the body possesses. Okay. So now again there are four types of brakes. That is the mechanical brakes, the hydraulic brakes, the electromagnetic brakes, and the three types of brakes only basically. Okay, because that hydraulic brakes will include both. That is the air brakes, the pneumatic and the hydraulic will be categorized into one category. So there will be only three types. That is the mechanical brakes. Okay, or let me write it down. Three types. First is mechanical brakes. Second one is hydraulic brakes. Hydraulic, or you can also write it as pneumatic brakes. And the third one is electromagnetic brakes. Okay. So these are the three kinds of brakes, the three classification. In the mechanical brakes, they are operated by mechanical means like bands, levers, etc. Hydraulic or pneumatic brakes are operated by air or oil pressure. Okay, oil pressure means it's a hydraulic brake, air pressure means it's a pneumatic brake. Similarly, for the electromagnetic, they are operated by magnetic field. Examples are magnetic particle brakes, magnetic hysteresis brakes, and eddy current brakes. These are the classifications of electromagnetic brakes. Okay, so now we will see the brakes in a much detailed. That is block brake. Block brake with short shoe. A block brake with a short shoe. Okay, so block brake with a short shoe means, see, if this is the kind of a brake, it has got this as a lining and this is the lever. This is hinged at some point O. This is the actuating force that is acting on it, that is P. This is the clockwise rotation of the drum. Okay, the clockwise rotation of the brake drum. What is the meaning of short shoe? Short shoe means there is this angle of contact between the brake, this is the brake lining, and the brake drum. This angle, that is alpha, alpha is less than 45 degree. That means it's a block brake with short shoe. So in this case, uniform pressure is there on this whole block. Okay, so uniform pressure is there, friction is used, so it becomes the similar case as we discussed in the uniform pressure theory for the clutches. Okay, so now this one, simple as this. If we take this distance as C, this distance as A, and this total distance as B. Yes, B, because it will be good for me to give you the expression directly. That's why I am seeing those dimensions there. Okay, so these are this way. So it's a very simple concept of the brake, how to do the analysis of the brake. Okay, we are considering the clockwise rotation of the drum. So what you have to do, you just have to draw the FBDs of both these things. Okay, this is the block which is attached to this lever. Okay, and the coefficient of friction is mu. The mu is the coefficient of friction. Okay, you don't have to do much in this. Okay, just understand the simple concept how to solve the questions of brake. You just have to draw the FBDs. So first we'll draw the FBD of drum, that is the brake drum. Okay, so this is the brake drum. This is rotating in the clockwise direction, having the radius, okay, having the radius as a small r, suppose. Okay, so if this is going in the clockwise direction, so at this point there will be a friction force. The friction force will be acting in the backward direction because at this point the brake drum will rotate in this direction, so the friction force will act in this direction, that is the friction force. Okay, and due to this block there will be the normal reaction that will be acting upwards, that is Rn, the normal reaction as this one. Okay, and you know one thing, that is frictional force is equal to mu into Rn, where this mu is the coefficient of friction. Okay, this mu is the coefficient of friction. Okay, so, and you know that the frictional torque Mt will be given by frictional force into the R, that is the radius. This we have discussed in the clutches as well. That is, frictional torque is equal to frictional force into R. Frictional force is equal to coefficient of friction multiplied by the normal reaction. Okay, now you draw the FBD of block. FBD of block. Okay, this is again very simple. This is the actuating force P. This is this point O. This is the block. Okay, so at the block, at this point of the block, if the friction was acting in the backward direction or in the right direction for the brake, for the drum, so for this it will act in this direction, that is FF, frictional force. Okay, this normal reaction will act downward for this one, that is Rn. Okay, and the dimensions you already know, this is C, this is A, and this total is B. So if you just see, if you just take the moments about O, this O is a hinge point, just take a moment about O and equate it to 0. Okay, so P into B, this will be the moment about O, that is P into B in the anti-clockwise direction. So P into B, this FF into C will also be an anti-clockwise moment, so this will get added up to this. FF into C minus this Rn is going downward, so Rn into A will be clockwise, so this will be a negative sign. Rn into A is equal to 0. Okay, so from here what you can find it out? From here you can find out, you can use the value of FF as mu into Rn. Okay, so you will get P into B plus mu into Rn into C minus Rn into A equal to 0. So from here, if you need to find out the frictional force, so first of all what you have to do, you have to find out the value of Rn, okay, in terms of actuating force. Substitute this value of Rn here, you will get the frictional force. Multiplied that by radius, you will get the frictional torque. Okay, that is one procedure. But here I will not use this procedure. I will find out the expression in terms of frictional force equating this P, that is the actuating force on one side. Okay, so for this I have to rub this one. See, P will be equal to Rn taken outside, A minus mu C divided by, A will go that side, become positive, minus mu C divided by B. So this is the expression that we get of actuating force in terms of normal reaction. Okay, that is A minus mu C upon B into Rn, that is the normal reaction. Now, there can be three cases. Okay, now see this expression, this is very important expression and the conditions which we are coming on. So there can be three cases now. The first case can be as case 1. this A is greater than mu C. Okay, if A is greater than mu C, then P will be positive. Then P will be positive. That means some amount of force is to be applied. Some amount of actuating force, or this actuating force is to be applied for the brakes to be applied. That means the operator can apply the brakes at his or her own will. Okay, so this kind of condition is known as self-energizing brake. Self-energizing brake. Okay, self-energizing brake means the brake has to be applied by the operator at his or her own will. For this, the condition is this. Okay, and the condition is this. You just now see how this condition came. When the P was this way, the frictional force was this side, and the normal reaction was this side. Okay, that means the torque, the condition comes like this. This question does not come like this. That is, A is greater than mu C is the condition for self-energizing brake. The question comes, the moment due to the actuating force and the moment due to the friction are on the same side. Because this is also about this point. About this point, if you take about O, the torque, the moment due to this friction force is in the anti-clockwise direction, and due to this actuating force is also in the anti-clockwise direction. That means the moment due to the actuating force and the friction force are both in the same direction. That is the condition for self-energizing brake. Okay. Next case comes when this A is less than mu C. A is equal to mu C. A is equal to mu C means P will be equal to 0. This is the case of self-locking. Self-locking brake means that the operator does not have to apply any kind of brake. If the geometry becomes like this of the block brake, that is A is equal to mu C, then the brake is already applied. You don't have to apply any kind of brake. The P will be equal to 0 in that case. Okay, and the third case comes, that is if A is less than mu C. If A is less than mu C, that means this P is less than 0. So this is the case of grabbing. In this case, the P is negative. That means the brakes are out of the control of the operator. Okay, and the operator cannot apply that brake. So that kind of condition is known as grabbing. So three conditions we have learned. A equal to mu C is the self-locking, A less than mu C is grabbing, and A greater than mu C is the condition for self-energizing brake. Okay. So this was about the block brake with short shoe. Okay. Now I will just give you one more here. Then I will very fastly move on to the band brakes. Okay. With long shoe. With the long shoe does not mean anything else. You just have understood that I have given you that the angle, the alpha was less than equal to 45 degree for the case of short shoe brakes. Okay, what was that alpha? If this is the engagement, this is the area of contact. This angle was alpha. So alpha was less than equal to 45 degree. That means it was a short shoe brake. And if we talk that alpha is greater than 45 degree. Alpha is greater than 45 degree. That means the uniform pressure will not be there, and this is the case of long shoe brake. Okay. So for that it is very simple. You have to use one thing, that is MT is equal to mu into N. Mu into basically the friction, this normal reaction into the radius. Okay, here it will be mu dash, and mu dash will be equal to mu sine theta 4 mu sine theta over 2 theta plus sine 2 theta. Just this expression, that is the coefficient of friction. The coefficient of friction will change, that is, sorry, mu dash is equal to mu into 4 sine theta divided by 2 theta plus sine 2 theta. Okay. Now, very fastly moving on to the topic of band breaks. Band breaks. Band breaks means in which there is a bands are used like this, okay, and then there is a this lever is there, okay. There is not the block, but there is a band around this drum and they are connected to this lever, okay. So there are two types, one is a simple band brake and the other one is the differential band brakes, okay. The simple band brake means if this is the fulcrum, okay, if this is the hinge point or the fulcrum, if one end of this band or this what you call as a rope, okay, or this friction material is passing through the fulcrum, then it's called a simple band brake. But if it is supposed like this, that the friction, that the fulcrum is here, but it is not passing, the neither ends of this rope or this friction material lining is not passing through the hinge point or the fulcrum, then this is called a differential band brake, okay. The analysis is very simple. Suppose this distance is A, this total distance is B, okay. Here if you can see this way, this is A, this is B and this is total as C, okay. So I will just make the analysis here only. So if this is moving in this direction, so cut it out here, you will have two tensions, that is T1 and T2, okay. So T1 and T2, if it is moving in the clockwise direction, T1 will be greater than T2 and T1 by T2 will be equal to mu into e raised to the power theta, where theta is the wrap angle of this rope or the friction lining material over the pulley or the brake drum, okay. So this is equal to this, and if you take the moment about summation of moment about O, you will get it as this will be 0 because this is T1 is passing through that point, so there will not be any moment of this T1 force the T1 tension from point A, so it will just be T2 into A in the anti-clockwise. Basically in this case the is applied into this side because otherwise the brake cannot be applied unless and until this brake drum gets stretched towards this lever, okay, or this friction lining material gets, means it catches the brake drum towards the lever, the brakes cannot be applied, okay. So this will be T2 into A minus P into B, okay, or from here you can find out T2 is equal to PB by A, okay. T2 equal to PB by A. Here from here you can find out T1 by using this equation, that is T1 equal to T2 into this, and you can find out the frictional torque as, in this case you can simply find the frictional torque as T1 minus T2 into R, that is R is the radius, okay. And if here the R is the radius, so here it is also very simple, you just have to do one thing, that is just remove this moving in the clockwise direction. So this will be T1, this will be T2, T1 greater than T2, T1 greater than T2, T1 by T2 is equal to mu power E theta, E power mu theta. Okay, so this will be, now we have to take the moments of all these three forces. Why? Because now neither of the point is passing through this fulcrum, that is O. Okay, so summation of moment about O equal to 0, that gives you P into, if we take the C only up till this point, all the distances are taken from this hinge point. So P into C will be in the clockwise direction. T1 into A will also be in the clockwise direction, that is P into C plus T1 into A minus T2 into B, that is equal to 0. Okay, so by all these things, that is the actuating force and all those dimensions of A, B and C, we can find out from this equation and this equation, we can find out T1 and T2, and we have frictional torque given by T1 minus T2 into the radius. Okay, so this is about the band brakes, that is the simple band brake and the differential band brakes. Okay, just this much you have to do in this. Okay, no more questions will come from in the JE level examinations. Okay, at most if the questions come from the topic of friction, clutches and the brakes, only this much can be asked. Okay, so now there are around 10-12 questions which I have for this session. I will take them up very fast. Okay, so let us see the first question. The first question says, which of the following is not correct? This is the question of brakes only. Which of the following is not correct? Give the answer for this one fast. Which of the following is said is not correct? Okay, which of the following is not correct? Those of you who are live right now can give the answers for this one. A brake is said to be a self-energizing brake when the moment due to friction is opposite direction to the moment due to effort. Second one, a self-energizing brake does not give self-locking. Third, a self-energizing brake avoids uncontrollable braking. And fourth is none of these. Give the answers fast, otherwise I will just keep on writing the answers for each and every question and move forward. There is no use of waiting for such a long. Okay, now the question have come in your screen. Just give the answers fast. Whatever answer you feel for these questions, then we will move on forward. Okay. Not interested it seems, no problem. A brake is said to be self-energizing brake when the moment, none of these, no. Try again, others please try. A brake is said to be self-energizing when the moment due to friction, I already told you what is the condition for self-energizing. Self-energizing means the moment due to the friction and the moment due to the effort are in same direction. It is saying a brake is said to be self-energizing brake when moment due to friction is in opposite direction. This means that this statement itself becomes incorrect. A is the right answer for this one. You don't have, none of you were present during the class. I don't know why. But none of you were attentive in the class, it seems. It seems that none of you were attentive in the class. No one is giving the right answer. Now I have got one answer from Akanksha. Amit Kashyap, Ankit Kashyap is now saying A. Okay, I have clearly mentioned this case that the brake is said to be self-energizing when the moment due to friction and the moment due to the effort were in same direction. Okay, Self-energizing brake does not give self-locking. This is absolutely correct. A self-energizing brake avoids uncontrollable braking. This is also absolutely correct. Okay, so A is the right answer for this one. Now moving on to the next question, it says that the torque transmitting capacity of a clutch can be increased by. So torque transmitting capacity of a clutch for the uniform wear theory it is saying. Now give the answer for this one. For the uniform wear theory, it is saying that how the torque transmitting capacity can be increased. Try this one, give the answer for this one fast. Torque transmitting capacity of the clutch can be increased by, assuming the uniform wear theory, increasing the plate pressure, assuming a friction material with a higher coefficient of friction, increasing the mean radius of friction disk, or all of the above. Give the answers fast, otherwise I am writing the answer and moving ahead. B is the answer. D is the answer. I am really disappointed with all these kind of responses which you are giving. I think that you, none of you were attentive during the class. This is not expected from you because you are not understanding the importance of the technical portion in the CBT 2 exam. Yes, D is the right answer because you know that MT is given by mu into P by 4 D plus D. Okay, so this you can also write it as 2 here, 2 here. Okay, so first statement says increasing the plate pressure. This is capital P, but this is not pressure. Remember, this is the total operating force. Total operating force. Okay, but this is directly proportional to the applied pressure. So if total increasing force increases, that means the pressure is also increasing. So A is correct. Using the friction material with a higher coefficient of friction. Yes, if this mu increases, this torque will also increase. Correct. And increasing the mean radius of the friction disk. This is the mean radius. That's why I separated 2 here. This is D plus D by 2 is the mean radius. Or the mean diameter you can say. Okay, if you will take this 2 as well here, that is D plus D by 4, this will become the mean radius. Okay, so this is also directly proportional, so this will also increase. So the answer for this one correct is option D. Okay, now moving on to the next problem. It says for the given dimension, the torque transmitting capacity of a cone clutch compared to that of a single plate clutch is. For the cone clutch, the transmitting capacity. What is a cone clutch? First of all, what is a cone clutch? The cone clutch is a kind of a clutch. I am telling you this. For the cone clutch, it is a kind of a clutch in which the plates are not, the engagement is not in this way, in the perpendicular direction. Okay. The friction linings are in somewhat in this direction. These are the friction linings for the case of cone clutch. Okay, and this angle is known as the semi-cone angle. Okay, so whatever formula we are getting in that, whatever formula we used to get in the case of a single plate straight clutches, the parallel clutches, in this that will be divided by 1 by sine alpha. That will be multiplied by 1 by sine alpha. Okay, that means if we write torque for cone clutches will be equal to 1 by sine alpha times of MT for the, suppose we write it as single plate clutch. Okay, because the single plate multiple clutches are all that in which the contact or the engagement disengagement take place in the parallel plates. Okay, so you know sine alpha value lies between 0 to 1. If we don't go into the negative side from 0 to 1, that means 1 by sine alpha will be greater than 1. Okay, that means the torque transmitting capacity of a cone clutch is higher than that of the single plate clutch. So the correct answer for this one is C. Okay, Now, moving on forward, this case. For the drum brake shown in the figure, the drum is rotating in the direction shown, that is in the anti-clockwise direction. The coefficient of friction between the drum and the shoe is 0.2. The dimensions shown in the figure are in mm. The braking torque for the brake shoe is. Okay. This is a very simple question. I am not going to discuss it here. Okay. And that's why I have not given the answer. Yes, that is more efficient compared to the single plate. But there sometimes comes the problem of grabbing and all in that. Okay, the grabbing problems also comes in the case of clutches. Okay, so one thing I am telling you that for this question I have not given you any options or anything. What you do, you just solve this question. It's a very conventional type of a problem. Okay, so braking torque you have to find out in Newton meters for this brake shoe. That is, you have to find out. So simply I am giving you the hint for this question. Draw the free body diagram, find out the normal reaction, okay, the frictional force from that and the frictional torque or the braking torque in this case, okay, and write the answer in the comment section. Okay, don't need to do this question right now, write this in the comment section. Okay, that will also make me understand, or it will also show that how much you are studying of your own as well, okay, after the session. So give me the answer for this one. What will be the maximum pressure in the plate clutch of outer radius 400 mm and inner radius 250 mm when the minimum pressure is 45 Newton per mm square? For this I am giving you one thing, that assume uniform wear theory. That is not mentioned there. Just take a note of this, that assume uniform wear theory. And now give the answer for this one. Maximum pressure in the plate clutch of outer radius 400 mm, inner radius 250 mm when the minimum pressure is 45 Newton per mm square. Give me the answer fast. See, for the case of uniform wear theory, we know that P into R is a constant. That means P inner, R inner will be equal to P outer into R outer. Okay, and we know that the P into R is constant, that means the minimum is given, so the minimum will be at the outer radius. Okay, so plate clutch outer radius is P inner, we have to, P inner is given. Okay, that is 45. No, this is to be found out. P inner is to be found out because it is given the minimum one. Into R inner is given as 250. P outer is given as 45. And to this is given as 400, I think. 400, yes. So, P inner will be equal to, or the maximum pressure will be equal to 45 into 400 divided by 250. Okay, just solve it and you will get the answer as 72 Newton per mm square. Okay, because this will 25 10 times, 25 16 times, this will be 4.5 and 4.5 into 16, that is 64 and 8, yes, 72 Newton per mm square. Okay, B is the right answer for this one. Moving on to the next problem, it says the efficiency of a riveted joint is equal to, the efficiency of the riveted joint is equal to what? PT by P, PS by P, PC by P, or least of PT, PS and PC by P. Give the answer for this one fast. The efficiency of the riveted joint is equal to, D is the right answer for this one. Okay, PT is the it is due to the tensile failure, PS is due to the shearing failure, and PC is due to the crushing failure. Okay, and divided by P. So the correct answer for this one is not A, not B, not C, it is D. Now moving on to the next problem, it says, this is the problem question from the topic of shafts. This says, when a when a shaft is subjected to combined twisting moment T and bending moment M, then the equivalent bending moment is equal to the equivalent bending moment when the shaft is subjected to both twisting and bending. So what is the equivalent bending moment in that case? Give the answer for this one. Equivalent bending moment for this case. Fast. Yes, C is the right answer for this one. Equivalent bending moment is this. Equivalent bending moment is given by C, that is half of M plus root of M square plus T square. Okay. Next is a key made from the cylindrical disc having a segmental cross section is. A key having a cylindrical disc made from a cylindrical disc having the segmental cross section is known as feather key, gib head key, Woodruff key, or flat saddle key. Give the answer for this one fast. Cylindrical disc, key made from a cylindrical disc having segmental cross section is known as which kind of a key? It's the feather key, gib head key, Woodruff key, or flat saddle key. It's not a gib head key, no. No. Cylindrical disc. No, B is not the right answer. Gib head key is not the right answer. C is the right answer for this one. Yes. It's called as a Woodruff key. Okay, it's a Woodruff key. That is a sunk key. So do you know the difference between the sunk key and the saddle key? Sunk key and a saddle key. Saddle key fits only on the hub. Okay, saddle key fits only on the hub, whereas the sunk key has the keyway on the hub and as well as on the shaft. Okay, so Woodruff key comes under the category of this one. That is this one. Okay. And what is the feather key? Feather key is the parallel key. If this is the kind of a shaft, so parallel key is, this is the feather key. Okay. This is the parallel key which prevents the axial movement between the hub and the shaft. This is known as Woodruff key. Somewhat looks like this. I don't have any image. You can search it on the internet, in the Google you can find it out. Okay, but it looks somewhat like this. The Woodruff key. Okay. It's a sunk key. Akanksha, what you are commenting, I am not able to understand that. Okay, if you have any doubt, genuine doubt, you can ask it. Okay, so this is the sunk key. What is the saddle key? I have already told you, it fits only on the hub. Okay, then move on to the next question that says, a tapered key which fits in the keyway in the hub and is flat on the shaft is known as. A tapered key which fits in the keyway in the hub and is flat on the shaft is. Which kind of a key is this? Which fits in the hub and is flat on the shaft. No. flat on the shaft. That is important. Flat on the shaft. It's a flat saddle key. Has a keyway in the hub. Keyway in the hub, that means it's clearly a saddle key. Okay. And it's flat on the shaft, that means it's a flat saddle key. It's not a gib head key. Gib head key has a gib head attached to it. There is nothing mentioned about the gib head. Okay. And it's not compulsory that the gib head key is only a taper key. Gib head key can be a parallel key as well. Okay, only the difference is that there is a gib head provided which facilitates the removal of the key. Okay, so the right answer for this one is D. Okay, don't get confused. The right answer for this one is D. That is a flat saddle key. Fits, first of all, it is given the fits in a keyway in the hub. Keyway on the hub is a saddle key. This is the way how these two keys are classified. The sunk key and the saddle key. Sunk key is a key which fits on both the hub and the shaft, and the saddle key is the key which fits only on the hub. Which fits only on the hub. Okay. So first of all, it is given that a tapered key which fits in a or I think basically that tapered word shouldn't be there, but even if it is given, it's clearly mentioned it has a keyway in the hub. So keyway in the hub means it's a saddle key, and it's a flat on the shaft, that means it's a flat saddle key. Okay, so the right answer is D for this one. Now moving on to the next one, it says the ratio of the driving tensions for the driving tensions for flat belts neglecting centrifugal tension is. Give the answer for this one fast. Ratio of driving tensions for flat belts neglecting centrifugal tension is. T1 by T2 has given some relation where T1 and T2 are the tensions on the tight and slack side. Mu is the coefficient of friction between the belt and the pulley, and theta is the angle of contact. Yes, C is the right answer for this one. T1 by T2 is equal to e raised to the power mu theta. Okay. Don't get confused with option B. Okay, if it would have been ln, because if it is T1 by T2 is equal to e raised to the power mu theta, and if we take the natural log, that is ln on both sides, so this will become ln equal to T1 by T2 is equal to mu theta times of ln E, and ln E is equal to 1. So this can be ln T1 by T2 is equal to mu theta. If it would have been this, then this would have also been the right answer. But in the B option, it is clearly mentioned as log. Log means base 10. This ln means natural log having the base as E. Okay, so the correct answer for this one is option C. Yes, C is the right answer for this one. Okay, now two closely coiled helical springs with stiffness K, K1 and K2 respectively are connected in series. This is the question from springs in series. Okay, this you might also know. In series, the stiffness of an equivalent spring is given by. The stiffness of equivalent spring is given by. Okay. If this suppose the mass, these are two springs having the stiffness as K1, K2 attached in series. Okay, attached in series. So you have to find out the stiffness of an equivalent spring. That's very simple. Okay, 1 by K is equal to 1 by K1 plus 1 by K2. Okay, or you will get K as K1, K2 divided by K1 plus K2. Okay, for the parallel case, it is just the sum. No, this one. Nikhil, Nikhil R and Madhuri Chavan, you are going somewhere wrong. It is not C, it is A. K1 K2 upon K1 plus K2, not K1 plus K2 upon K1 K2. Okay, that's the reciprocal of that. A is the right answer. Yes. Okay. Now, moving on to this problem, this says for the shoe brake, this is the last question of the day. Okay, for the shoe brake, the equivalent coefficient of friction is equal to. Okay, it's not mentioned here, but it's very understood from the language of the question. The equivalent coefficient of friction is equal to, it's talking about the block brake with long shoe. Okay, the block brake with long shoe. So, what is the equivalent coefficient of friction? What is that? See the options very carefully and answer. Is it 2 mu sin theta over theta plus sin theta, or is it mu sin theta over 2 theta plus sin 2 theta, or is it 4 mu sin theta over theta plus sin theta, or it is 4 mu sin theta over 2 theta plus sin 2 theta? This is the last question of the day. Okay, last question of the day, last class of the machine design as well, and could be the last class for this Gearup JE plan as well. Okay, because of seeing the response of these students, okay, you all are learning, that's good, but we are not getting this much good response from all of your sides. So maybe I cannot assure you anything about this plan now. Okay, we were looking for a comprehensive plan for 50 plus videos in this free YouTube series, but since we are not getting a good response from our students, okay, in the live classes, so we may think of winding up these YouTube video sessions. Okay, there is a chance for that. So, but even if that does not happen, this is the last class for machine design. Okay, so give the answer for this one. Yes, you all are giving the answer correct. D is the right answer. This I have already told you, nothing much to be explained in this. That for the block brake with a long shoe, the equivalent coefficient of friction is equal to 4 mu sin theta over 2 theta plus sin 2 theta. Okay, so thank you for attending this live session. I hope you might have learned something from this. Okay, so for all those who have purchased the paid course, I can promise you that we will meet on 15th with our first class of the subject of engineering mechanics. But for this YouTube series, the Gearup JE series, I don't know that whether we will meet again or not, because I am not very sure that we will be continuing with this series for a very long. Okay, but for those students who have purchased the video course or anything of that, okay, only CBT 1 plus means CBT 1 plus 2 or only the CBT 2. Okay, so there we will be starting our classes from 15th of April, that is from this coming Monday. Okay, so thank you all for attending this session. Okay, and I had a nice interaction with you. So thank you, take care, bye.